All right, today we're tackling one of the biggest, most, mind-bending questions out there. We're talking about consciousness. And we're going to explore a really wild theory that says the answer isn't in biology as we know it, but deep inside the quantum world. I mean, seriously, just stop and think about it for a second. Where does that feeling of being you actually come from? The experience of seeing the color red or feeling happy, it's literally the most fundamental thing we know. But for scientists, it's a total black box. How does this squishy biological computer in your skull create the rich, vivid inner movie that is your life?
Yeah, there's actually a name for this. Philosophers call it the hard problem of consciousness. See, explaining how the brain processes information, like how it recognizes a face or catches a ball, that's considered the easy problem. We're making progress there. But the hard problem, that's explaining why any of that processing should feel like anything at all. Why isn't it all just dark inside? That's the real mystery.
So to try and crack this nut, some scientists came up with a pretty radical idea. They asked, what if we've been looking in completely the wrong place? What if the secret to consciousness isn't in classical textbook neuroscience, but in the bizarre probabilistic world of quantum mechanics?
And this leads us to a specific theory, and it's a mouthful: orchestrated objective reduction. Most people just call it ARC-OR. It's the brainchild of the brilliant physicist Sir Roger Penrose and an anesthesiologist named Stuart Hameroff. Their big claim? That the standard model of neurons firing like little computer bits, it just isn't powerful enough to create consciousness. The real action, they believe, is happening on a scale that's way, way smaller, down at the quantum level. Okay, so how does it supposedly work? Let's break it down. Inside our neurons, we've got these tiny protein tubes called microtubules. The theory says quantum vibrations start inside these tubes. Now, these vibrations go into a state of superposition, which is a fancy way of saying they exist in multiple states at the very same time. Think of it like a spinning coin before it lands. Then, these quantum vibrations link up across the whole brain until, poof, they hit a certain point and collapse into one single reality. The coin lands. And according to Orr, that very moment of collapse, that's a flash of conscious experience. The idea for the biological part of this came from a place you might not expect. Stuart Hameroff wasn't even studying consciousness at first. He was looking at how cells divide, and he just became fascinated by these microtubules. He saw them acting with what looked like, intelligence. He started thinking, hey, maybe these aren't just the cell's skeleton. Maybe they're tiny computers. And that idea became the perfect biological home for Roger Penrose's quantum physics.
Okay, but let's be real. As you can probably guess, when this theory came out, the scientific community, they didn't exactly roll out the red carpet. It was hit with a huge wall of skepticism. For decades, most mainstream scientists thought it was just completely bonkers. And there was one massive, killer argument they always used.
And here it is. It's called the warm, noisy brain problem. See, to get quantum effects to work in a lab, you basically have to create a super cold, super isolated environment. We're talking near absolute zero. But the human brain, it's the total opposite. It's warm, it's wet, it's a chaotic storm of electrical signals. So the critics had a really simple and frankly devastating question. How on earth could a fragile little quantum state survive in that chaotic environment for even a nanosecond? It seemed impossible.
So yeah, the case against quantum consciousness was pretty strong. You had the biological implausibility, that warm, wet brain problem. You had a total lack of direct evidence. Some people even said, hey, you're just replacing the mystery of consciousness with the mystery of quantum mechanics. That doesn't help. Plus, classical neuroscience was doing just fine on its own. Thank you very much. For a really long time, it felt like the debate was over. Case closed. But then, things got interesting. Just when it looked like this theory was completely dead and buried, a couple of surprising new experiments came out of nowhere, and they blew the whole debate wide open again.
You see, the story doesn't end there. All of a sudden, what everyone thought was impossible started to seem, maybe not so impossible after all. We started seeing new research that took a direct shot at those huge criticisms that had kept the theory on the fringes for so long. And the first real bombshell came from a team in Dublin. They were using a brand new kind of MRI technique, specifically looking for signs of quantum entanglement in the brain. And their conclusion was, honestly, it was stunning. They said they found signals that, in their view, could only be explained by quantum processes. And what's more, those processes seemed to be directly tied to being conscious.
So what exactly did they do? Okay, a normal MRI just picks up on classical brain signals. But this new technique was looking for something very specific, a potential marker for quantum entanglement. And here's the kicker, the most amazing part of their finding. This weird signal was there when people were awake, but when they fell asleep, it got weaker and then disappeared entirely. This was a huge deal. It was maybe the first time anyone had found a potential quantum signal in the brain that switched on and off with consciousness. At pretty much the same time, a completely different group of scientists, this one including Stuart Hameroff, one of the theory's original creators, decided to go right for the jugular. They wanted to test the absolute core idea of ORCOR, those quantum vibrations inside the microtubules. And what they found was, again, just fascinating. First off, they actually measured quantum effects in these microtubules at body temperature. That right there is a direct challenge to that whole warm, wet brain problem. But then came the really clever part. They added general anesthetics, the stuff that specifically turns consciousness off. And when they did, these quantum effects got way shorter. They were significantly dampened. And get this, they tried a similar drug that doesn't cause anesthesia, and nothing happened. It's a pretty compelling clue suggesting a direct link between these quantum vibrations and the on-off switch of consciousness. So where does that leave us in all of this? Well, we've gone from a theory that was pretty much dismissed as pseudoscience to what is now a really active and, pretty unsettled scientific frontier. Now let's be super clear here. None of this new evidence proves that ORCOR is right. We are not there yet, but what it does do is pretty remarkable. It offers the first real experimental counter-arguments to those killer criticisms that held the theory back for decades. It basically takes the word impossible off the table. So let's recap where the debate stands right now. That old idea that the brain is just too warm and messy for quantum mechanics? Well, new data says maybe not. For the very first time, we have actual experimental hints, again, hints, not proof, that tie quantum weirdness directly to being conscious. The whole conversation has shifted. It's not about dismissing the idea anymore. Now it's about figuring out how to investigate it seriously. And so we're left with this truly tantalizing question. Could it be that the answer to our biggest mystery, what it means to be me, is hidden in the universe's smallest, strangest rules? For so long, we've tried to understand the mind using classical physics. But maybe, just maybe, the key to our own inner world lies in the bizarre and wonderful logic of the quantum realm. We are a long, long way from an answer, but the search has suddenly become one of the most exciting quests in all of science.